Hello boys and girls, welcome back to Project Infinity. Today we will complete all questions from Electrostatics asked in Jee Main 2024 Jan attempt. So let's get started. So here is our first question. The electrostatic potential due to an electric dipole at a distance r varies as. So we know if dipole is in this direction P and we need to find a potential at any point. Suppose this is the point Vp. This Vp is equals to Kp cos theta, where theta is this angle, by r square. So I can see that Vp is proportional to 1 by r square. So option 2 is the correct answer to our question. If you want a dedicated video with these formulas of electrostatics, please comment down below. These formulas are very much important and sometimes direct questions come from these in Jee Mains. So let us move on to the next questions. So here is our second question. A particle of charge minus q and mass m moves in a circle of radius r around an infinite long line charge of linear density plus lambda. Then time period will be given as. So first of all, let us draw this infinite long line charge. This is infinitely long, given as plus lambda linear charge density. A particle of charge q. This is the particle. Charge q, mass m. This is revolving in a circle of radius r. So definitely, since this is revolving around this, centripetal force will act in this direction, and also this centripetal force is provided by QE, where E is electric field due to this infinite long line charge. Here E will be 2k lambda by r. These are important formulas. Again I am telling you, if you want this in a dedicated video, please comment down below. So Q into 2k lambda by r, this is equals to m omega square r. This is centripetal force. So from here, again omega is what? Omega is 2 pi by t. We know this. So omega square, I will replace it with 4 pi square by t square. So ultimately from here I will get q into 2k lambda by r. This is equals to m 4 pi square by t square into r. So t square from here, t square, this is equals to m 4 pi square into r. Again r square will come by 2k lambda and q. So t is 2 pi r m by 2k lambda q under root. So I have found time period. This was only asked in the question. Then time period will be. So looking at the options, I think option number 2 is t equals to 2 pi r m by 2k lambda q under root. So this is the correct answer to our question. So this is our next question. Two identical charged spheres are suspended by strings of equal lengths. The string make an angle of 37 degree with each other. When suspended in a liquid of density 0.7 gram per cc, the angle remains same. If density of material of the sphere is 1.4 gram per centimeter cube, the dielectric constant of the liquid is. Now this is a very interesting question because this statement, it is told that when suspended in a liquid of density this much, the angle remains the same. Now suppose this is our first situation. The angle is 37, whatever it is, it doesn't matter. Now two identical charged spheres, these are equal length strings, and if I try to draw the FBD, downward force mg will act. In this direction F electrostatic will act because repulsion between these two, and tension in this direction. So suppose this is theta angle. I know it is given 30, so 37 with each other. So 37 by 2 theta will be whatever. This is t cos theta and this one will be t sin theta. So I will get t sin theta equals to Fe, not mg, Fe, and t cos theta, this is equals to mg. From here tan theta, this is equals to Fe by mg. So I have got this relation. Now it is again suspended in the liquid. This is the second situation. These are the two spheres, and suppose this is the liquid. Now here also, if I draw the FBD, mg will act, tension T will act, F electrostatic will act, and it is told in the question angle is same. So again theta. This was the beauty of this question. Now since it is placed inside a fluid, another force, F buoyant force will act, and I know the formula of buoyant force Fb. This is equals to V rho g, and V is volume of the sphere In the question nowhere it is given the volume, but we know mass, so mass by density is volume, and this rho is rho of liquid in which it is immersed into G. So I will get mg rho liquid by rho. This I will use later on. So in this case, t sin theta, wait, t cos theta is again this, and t sin theta is again this. So again I will do t cos theta. Wait, first t sin theta I am doing. T sin theta will be Fe, and t cos theta, this will be this time mg minus Fb. So again I will get tan theta equals to Fe by mg minus Fb. Now why I told that 37 is of no use? Because I need to just equate both the tan thetas. So it doesn't matter what is the angle. So I will equate both the equations. Fe by mg, this is equals to Fe by mg minus Fb. And it is told that dielectric constant. One thing is that in the second situation, the F electrostatic, this will not be Fe but Fe by K, because there is a dielectric medium, so Fe by K. So here also Fe by K. So cancelling Fe, I will get 1 by mg, this is equals to 1 by K, mg, and Fb I have found out. I told you that I will use this relation. So mg rho L by rho, mg rho liquid by rho. So mg gets cancelled from both sides. I will get 1 by, so 1 equals to 1 by K times 1 minus rho L by rho. So I will get K times 1 minus rho L by rho. This is equals to 1. So K times 1 minus rho liquid in the question was given as 0.7 gram per centimeter cube. So 0.7, and rho of the sphere, material of the sphere, is 1.4 gram per cc. So 1.4. So this is K into half. This is 1. So ultimately I will get K equals to 2. So I found out the dielectric constant of the medium in the question. The dielectric constant of the liquid is 2. So 2 is the correct answer to our question. So here is our next question. Two charges Q and 3Q are separated by a distance r in air. At a distance x from charge Q, the resultant electric field is 0, the value of x. So in the given question, this is charge Q, this is charge 3Q, and this distance is r. Now since both are given as same polarity, so I know that electric field will be 0 somewhere here, E is 0. And it is given x from charge Q, so this is x, this is r minus x. So I need to equate the electric field over here. So kq by x square, this is equals to k 3 cube r minus x whole square. So k gets cancelled, so I will get r minus x, this is equals to root 3x. So r, this is equals to root 3 plus 1 into x. So ultimately x is r by root 3 plus 1. So this is our solution. Option number 3, r 1 plus root 3 is our correct answer. So here is our next question. Force between two point charges Q1 and Q2 placed in vacuum at r centimeter apart is F. Force between them when placed in a medium having dielectric K equals to 5 at r by 5 centimeter apart. So first of all, F, this is equals to K Q1 Q2 by r square. This is equation number 1. Now second F, F2, let this be F1. This is equals to K Q1 Q2, dielectric constant K equals to 5. This K is different from this, okay. So 5 and r square, here r by 5. So r square above 25. So I will get 5K Q1 Q2 by r square, equation number 2. So from 1 and 2 you can definitely see that F2 is 5 times F1. So this is asked in the question. So 5F is the correct answer, option number 2. Question number 6. The distance between charges plus Q and minus Q is 2L, and between plus 2Q and minus 2Q is 4L. So we are given two information. You can also see the figure given on the right side. The electrostatic potential at point P at a distance r from center O is in this format. The answer will come. I have to find the value of alpha. So before that, I think you know how to write dipole. Minus Q to plus Q. This is a dipole. Let me take a different color. This is a dipole, and minus to plus, this is another dipole. This is let P1 and this is P2. What will be P1? P1 is between this So it is charge into length, so 2ql, and P2 is charge is 2q and distance is 4l, so 8ql. So I know how to write the potential. Vp, this is kp cos theta by r square. This is the primary formula. But in the second situation, the angle will be this angle, and this angle is 120 degree. So V1, this is for dipole moment P2. This is equals to K, P is 8QL cos of 120 degree divided by R square. Now V2, this is for P1 dipole. This is K, 2QL cos of 60 degree by R square. So V net potential is V1 plus V2. V1 will come out, cos 120 is what? Minus half. So I will get minus 4kql by r square, and cos 60 again half. So I will get kql by r square. So ultimately V1 plus V2 is minus 4kql by r square plus kql by r square. So this is minus 3 kql by r square. And the question, I am given a format in this way. So writing this minus 3, what is the value of k? 9 into 10 to the power 9 ql by r square. So ultimately minus 27 ql by r square into 10 to the power 9. Now if you look carefully, this is only our format, where minus alpha will come out to be minus 27. Minus alpha is minus 27, so alpha is 27. This was the correct format. So the correct answer, where the value of alpha is 27. So this is our next question. Two identical charged spheres are suspended by strings of equal lengths. The strings make an angle theta with each other. When suspended in water, the angle remains the same. This is an important line. Angle remains the same. If density of the material of the sphere is 1.5 gram per cc, the dielectric constant of water will be. So we need to find the dielectric constant. So let me take it as K. Now let me draw the figure. It is given that the strings make an angle theta. So let me draw the strings in this way. These are the charged spheres. Identically charged sphere, angle is theta between them. Therefore this angle will be theta by 2. Here also theta by 2. Now we need to draw the FBD for one sphere. So for this sphere, downward direction mg will be acting. And notice these are charged spheres, so they will have charge. So in this direction an electrostatic force Fe will be acting, because similar charges, so there will be repulsion. In this direction tension. And now you know how to convert a given force into its components. So here T can be converted in this way. This is T cos theta by 2. And in this direction T sin theta by 2. Now observe carefully. T sin theta by 2. This is our F electrostatic force. And T cos theta by 2. This is our mg. This is how the forces are balanced. So if I divide the two equations, I will get tan theta by 2. This is equals to Fe by mg. Now this is an important relation. We will make use of this relation. So proceeding further, I know that force is electrostatic force Fe. This is 1 by 4 pi epsilon naught q square, because charge is similar, by distance is r square. Now suppose a different material is placed. I know that this force is written only when the medium is air, epsilon naught. Now when different medium will be placed, we will get a dielectric constant of that medium. In that case, F electrostatic, I will get 1 by 4 pi epsilon naught q square by r square. Same thing, only thing is a dielectric constant will be added in the denominator. So K is in the denominator, our dielectric constant I have assumed K. Now see, in the question we are given that When suspended in water, here water is our medium, the angle remains the same. If the angle remains the same, I can use the same angle theta by 2. Again the same figure will happen. So if I draw it again, suppose this is the situation. When our body is placed in water. Now in this situation, let me draw the FBD. So this angle is again theta by 2. Downward mg is acting. In this direction, F electrostatic. This is different electrostatic, so I am representing it Fe dash. In this direction, tension will be acting. So again I am converting it into components, T cos theta by 2, and in this direction T sin theta by 2. Now another force which will be acting is the buoyant force, because this is water. The buoyant force will be acting in this direction. This is FB. Now in this case, which I will get is T sin theta by 2. This is our Fe dash, and T cos theta by 2. This is mg minus FB, because T cos theta by 2 plus FB, this will balance out mg. So again I will get tan theta by 2. This is equals to Fe dash by mg minus FB. So now we have got two relations. I will simply equate both of these equations and find out the result. I hope you understand how I am doing. Now equating them, Fe by mg, this is equals to Fe dash by mg minus Fb. Now before that, let me tell what is Fb, buoyant force. Fb, this is equals to V rho liquid into G. V is what? V is the volume of the sphere immersed. Now volume, I don't know in the question, I know where it is given, where is volume, but I know that density is mass by volume. So from here volume is mass by density. Now here mass I know, m I have already taken mg, and density is given as 1.5 gram per cc, density of the material of the sphere. So volume I will get mass by rho. So m by rho into rho liquid into G. So simply putting this, Fe, this is equals to, and Fe dash is Fe by K, the dielectric constant, denominator mg, and here mg minus Fb is mg into rho liquid by rho. Now if we subtract mg from both sides, and also F is also cancelled and mg is cancelled, I will get 1. This is equals to 1 by K divided by 1 minus rho liquid by rho, right? So now what I will get, 1 by K times 1 minus rho L by rho, this is 1. So from here K times 1 minus, what is rho L? Rho L is given in the question. Take density of water 1 gram per cc, we also know the value. So 1 divided by rho is 1.5. So 1.5 I am writing 3 by 2. This is equals to 1. So K into 1 by 3, this is equals to 1. So from here K equals to 3. See, calculation was easy, but you need to know how I have done this. Interpret the question properly, and you will find that the dielectric constant of water is 3. So 3 is the correct answer to this question. So here is our next question. C1 and C2 are two hollow concentric cubes enclosing charges 2q and 3q respectively as shown in the figure. The ratio of electric flux passing through C1 and C2. So we know electric flux, this is equals to Q enclosed by epsilon naught. So basic formula based question. See, C1 is enclosing 2q charge. So this one is C1 and this bigger sphere is C2. So from here I can say charge enclosed by C1, this is 2q by epsilon naught, and charge means flux of C2, this is 3 plus 2, 5q, because enclosed is 5q by epsilon naught. I need to find the ratio of electric flux passing through C1, flux C1 by flux C2. This is simply 2q by epsilon naught by 5q by epsilon naught. So this is 2:5. So I can see option number 1 is 2:5. So this is the correct answer to this question. This was a basic question. We need to know this formula. Flux is q enclosed by epsilon naught. So here is our next question. An electric charge of 10 to the power minus 6 microcoulomb is placed at origin 0, 0 of xy coordinate system. 2 points P and Q are situated at √3 meter and √6, 0 meter respectively. The potential difference between the points P and Q. For easy understanding, I am drawing the figure. Let me assume that this point is VP. Coordinate is given as √3, √3. And this position where I will find the potential VQ. This is given √6, 0. And this is our origin. Electric charge of 10 to the power minus 6 microcoulomb. This is placed at origin. Now if we calculate the distances, this distance is √6 obviously, and this distance is also √6. √3 square plus √3 square in under root, so √6. Now we know potential, this is written as KQ by R. Now in both VP and VQ, the distance is same. This is √6. So I can say that VP, this is equals to VQ. Therefore VP minus VQ, this is equals to 0. The potential difference between the points P and Q will be 0 volt. So option 3 is the correct answer to our question. Question number 13. Suppose a uniformly charged wall provides uniform electric field of 2 into 10 to the power 4 Newton per coulomb normally. A charged particle of mass 2 gram being suspended through a silk thread of length 20 centimeter and remains stayed at a distance of 10 centimeter from the wall. Then the charge on the particle will be. So let us first draw this. Let us assume that this is our wall. And this wall is providing a uniform electric field in this direction. Electric field. This is 2 into 10 to the power 4 Newton per coulomb. Okay. I have also given that there is a silk thread which is of 20 centimeter. Stayed at a distance of 10 centimeter. So this is 10 centimeter. And now if I draw the FBD of this small particle of mass 2 grams, M, this is 2 grams, in this direction of force QE is acting, downward direction mg, and in this direction tension. Now converting this into its components, T cos theta, where theta is this angle, and here it is T sin theta. Now I can say that T sin theta, this is QE, T cos theta, this is mg. So from here, dividing both equations, I will get tan theta, this is equals to QE by mg. Now ultimate goal is to find tan theta. See in this triangle, the purple triangle, the hypotenuse is 20 centimeter, base is 10. So I can find this side. This side is 20 square minus 10 square. So 400 minus 100, 300. So 10 √3. So tan theta, this is 1 by √3. This is equals to QE by mg. Now substituting the values, I will get 1 by √3. This is equals to Q into E is given 2 into 10 to the power 4. And mass was 2 grams, so 2 into 10 to the power minus 3. And G is given as 10 meter per second square. So into 10. So cancelling this. So Q I am getting 1 by √3 into 10 to the power minus 6. Here minus 3 and from here again minus 3. So I will get 1 by √3 microcoulomb. Now going back to the question. Then the charge on the particle will be 1 by √x microcoulomb. So I have found 1 by √3 microcoulomb. So from here I can say that x is 3. So this is the final answer. So 3 is the correct answer to this question. So here is our next question. It says two charges of minus 4 microcoulomb and plus 4 microcoulomb are placed at the points A is given as 1, 0, 4 meter and B is given as 2, minus 1, 5 meter located in an electric field E is 0.20 I cap V per centimeter. The magnitude of the torque acting on the dipole is. So to find the magnitude of torque. So I know, let us take A is 1, 0, 4 and B is 2, minus 1, 5. So if this is A and this is B, this direction is R vector. So R vector, this is equals to 2 minus 1, so I cap, minus 1 minus 0, so minus j cap, 5 minus 4 is plus k cap. This is our R vector. I need to find the dipole moment. So dipole moment, this is P. I usually write dipole moment as P. So this is Q into R. Here Q is 4 microcoulomb. So 4 into 10 to the power minus 6. I can write minus 4 plus 4, doesn't matter because I am interested in the magnitude. R is I cap minus j cap plus k cap. Now torque is P cross E. This is a very important formula. Many times questions have come with this formula. So torque, we are getting P is 4 into 10 to the power minus 6 I cap minus j cap plus k cap cross, this is I cap 0.20 I cap. So this will come 8 into 10 to the power minus 5 and I need to find a cross product. So you should remember this diagram. This is I cap, this is j cap and this is k cap. If we move in this direction, clockwise direction, I cross j will yield k, k cross I j and so on. If we again move in counterclockwise or opposite direction, I will get a minus sign. So using this, I cross I is 0, minus j cross I, j and I is minus k, again minus, so plus k cap and k cross I is j cap. I need to find the magnitude of this. So magnitude of k cap plus j cap, magnitude, these are unit vectors, so magnitude is root 2. So I will get 8 root 2 into 10 to the power minus 5 Newton meter. This is torque. And in the given question, it is said that 8 root A into 10 to the power minus 5 Newton meter. So comparing, I can see that A is our 2. So value of A is 2. This is the correct answer to our question. Question number 15. A thin metallic wire having cross-sectional area of 10 to the power minus 4 meter square is used to make a ring of radius 30 centimeter. A positive charge of 2 pi coulomb is uniformly distributed over the ring, while another positive charge of 30 picocoulomb is kept at the center of the ring. The tension in the ring is, okay, it is also given that provided that the ring does not get deformed, neglect the influence of gravity. So let us first draw the ring. So this is a ring. It is given that the radius is 30 centimeter. So capital R radius is 30 centimeter. A positive charge of 2 pi coulomb. So let me draw the positive charge uniformly distributed over the ring. So total charge is 2 pi coulomb. And at the center, positive charge of 30 picocoulomb. So 30 picocoulomb is at the center. Now we need to find the tension. So we have already known that to find the tension, we take elements. Let us take this small element. I have drawn it big just for clarification, but this is a very small element. So let the element be this, where this is the center of the ring. Charge here is small q, which is 30 picocoulomb. This is the positive charge on the arc. And let me assume that this small angle is 2d theta. So this small angle will be d theta. So here also d theta angle subtended. Now I can say that tension will be in this direction, T. Why? Because we have already studied that tension always acts along the body. Now if you want to convert this into its components, so this will be its two components. So if this small angle is d theta, I can say that this small angle will be d theta. So similarly this small angle will be again d theta. So converting them, the downward force will be t sine d theta, and in this direction t cos d theta. Here also t cos d theta, and downward is t sine d theta. And we are forgetting one force, most important force, which is acting from the center line. This force is the electrostatic Fe. Now if you look carefully the FBD, I can see that this t cos d theta and t cos d theta on the other side will get cancelled. So only force which is balancing is 2t sine d theta, the downward force, which will balance our electrostatic force Fe. Why they will balance? Because in the question it is given the ring does not get deformed. That's why they will balance. Now one thing we know that this d theta angle is very small. For small angles, I am writing it in this side. Sine theta, this is roughly equals to theta if theta is very small. So I am using this and writing 2t sine d theta will be d theta. This is equals to our electrostatic force Fe. So I will use this equation again. Now let us find what is the electrostatic force acting. Now for F electrostatic force, Fe, this is k q1 q2 by r square. So k, q here is small q, which is the 30 picocoulomb, and the capital Q will be only for this arc length, this arc, because I have taken a small angle subtended. So we know that if this is our arc, this is radius r, and angle subtended is d theta. Here it is d theta plus d theta, 2d theta. So this arc length L, this is equals to r into 2d theta. This is how we calculate the arc length. So the charge on this arc will be total charge Q divided by total arc 2 pi r circumference into r 2d theta. This is our charge. And this is k q1 q2 and whole divided by r square. So this is our electrostatic. Now I will make use of this equation over here. So 2t d theta, this is equals to k small q capital Q r 2d theta divided by 2 pi r into r square, and simply cancel d theta from both sides. Here r gets cancelled, here 2 also gets cancelled from both sides. So we are left with the equation t equals to k small q capital Q by 2 pi r square. So this will be our final equation. Now we just need to put the values given in the question and find the value of tension. So from here, tension T, this is equals to K, I think given in the question, 1 by 4 pi epsilon naught, to be taken as 9 into 10 to the power 9. So 9 into 10 to the power 9. Small q is 30 picocoulomb. So 30, and pico is 10 to the power minus 12 into capital Q was given 2 pi coulomb. So 2 pi divided by 2 pi, and R was given in the question as 30 centimeter. So into 30 centimeter means 0.3 meter. So 9 into 10 to the power minus 2 in meters. So 2 pi gets cancelled, 9 gets cancelled. So I am left with 3, and from here into 10 to the power 9, then again 9. So all 10 to the power 0. So 3 is only left. So 3 Newton. So the final answer, tension, is 3 Newton. We have found the tension. Next question is an assertion reason based question. Let us read the assertion. Work done by electric field on moving a positive charge on an equipotential surface is always 0. We know that equipotential surface, suppose this is an equipotential surface, definitely electric field will be perpendicular to this. So electric field will be in this direction, and work done by electric field on moving a positive charge on an equipotential surface, which means the positive charge Q is moved in this direction. So this is the charge movement, and the force is QE, and the direction is in this way. So 90 degrees is the angle between the charge and the force. So work done will be dot product of force and displacement. So dot product will be always 0, cos 90 0. So always 0 is the correct. So assertion here is correct. Given reason is electric lines of forces are always perpendicular to equipotential surface. So this is definitely the correct reason. I have shown right here that electric lines of force is perpendicular to equipotential surface. So I think both A and R are correct, and R is also the correct explanation. So option 4, both A and R are correct and R is the correct explanation of A. This is the correct answer to this question. Question number 17. The electric potential at the surface of an atomic nucleus Z is 50 of radius 9 into 10 to the power minus 13 centimeter is. So very simple formula based question. Potential is V equals to KQ by R. K is 9 into 10 to the power 9. We already know the value. Now charge Q will be 50 into Z is 50 and we know charge is ZE. So ZE value is 1.6 into 10 to the power minus 19 coulomb. And R is given radius is 9 into 10 to the power minus 13 centimeter. We have to convert it into meter. So 9 into 10 to the power minus 15. So if we cancel out minus 4, so here 5, 9 gets cancelled. So ultimately I am getting 15 to 1.6. So 5 into 1.6, 8 into 10 to the power 6 volt. So I have to find the value. So 8 is the correct answer to this question. Question number 18. Now this is a very good question. An electron is moving under the influence of an electric field of a uniformly charged infinite plane sheet S, infinite plane sheet having surface charge density plus sigma. The electron at t equals to 0 is at a distance of 1 meter from S and has a speed of 1 meter per second. The maximum value of sigma if the electron strikes S at t equals to 1 second is. So we are given this format and ultimately I have to say what is the value of alpha. So let us first draw the figure. Suppose this is our infinite plane sheet. It is given in the question that this infinite plane sheet is having plus sigma surface charge density. So this infinite plane sheet will have electric field in this direction and electric field will be E equals to sigma by 2 epsilon naught. I hope you know this formula. Now suppose an electron is in this position which is 1 meter from this infinite plane sheet, and it is also told that this electron is having a speed of 1 meter per second. So 1 meter per second. Now the question may arise, why I took 1 meter in this direction? Because I can also take 1 meter per second in this direction. I can also make an angle 1 meter per second. Why I took only this direction? So if you can answer, you can comment down below. But let me tell you. See, in the question it is given the maximum value of sigma if the electron strikes S. So I need to find the maximum value of this sigma. Now suppose that this electron is moving in this direction and acceleration is also in this direction. Do you think I will get the maximum force required to stop this electron to come at this infinite plane sheet? No. Suppose the electron is moving in this direction, force which is QE, it is acting in this direction. Do you think I will get the maximum force required? No, because only the component of this force in this direction will affect movement of this electron. So for maximum value of sigma, I definitely have to take in this direction the speed which is V, and in this direction the force, it has to be maximum, force maximum in order to stop this electron. I hope you understood why I took the said speed in this direction. So now let us solve. Now this becomes a basic kinematics question, and let me take this side as the positive direction and this side is the negative direction. So let me draw it again for simplicity. This is our electron E. It is going in this direction 1 meter per second u initial speed, and in this direction acceleration is QE by m. Here Q is E, charge of electron, so E capital E by m. And also I know E is, here I have written sigma by 2 epsilon naught. So ultimately A is E sigma by 2 epsilon naught m. Now I have to find, again S is also given, S is 1 meter, T is also given as 1 second. So now I will use the basic equation S equals to ut plus half at square. Putting the values, S is in the negative direction, so -1. U is in the positive direction, 1. Time is also 1 second. Plus half. Now A is in the negative direction, so I'm taking negative over here. Negative half. A is E sigma by 2 epsilon naught m, and T square is 1 square. So ultimately -2, this is equals to -1 by 2 E sigma by 2 epsilon naught m. So from here I will get 8 equals to E sigma by epsilon naught m. So from this equation, sigma is 8 epsilon naught m by E. So this is our final equation. Now in the question it is told that I have to write in this format. See, alpha m epsilon naught by E, and this is equals to our 8 epsilon naught m by E. I think you can compare from here that alpha is 8. So I will get the final answer, alpha, this is equals to 8. And in the question I was asked the value of alpha, so 8 is the correct answer to our question. Question number 19. Two charges of 5q and -2q are situated at the points 3a, 0 and -5a, 0 respectively. The electric flux through a sphere of radius 4a is having center at origin. So let me draw the sphere. This is our coordinate system. So this is our origin, and the center of this sphere is the origin. 5q is situated at 3a, 0. Definitely this point will be 4a, 0 because radius is 4a. Here it is given. So this is 5q charge at 3a, 0, and -5a will be somewhere here, -5a. Here I have -2q charge. So definitely flux through sphere, q enclosed by epsilon naught. Q enclosed within the sphere is only 5q, so 5q by epsilon naught. I see option number 2, 5q by epsilon naught. This is the correct answer to our question. So next question, an electric field is given by 6i cap plus 5j cap plus 3k cap unit Newton per coulomb. The electric flux through a surface area 30 meter square lying in yz plane. So this is definitely a formula based question. I have to find electric flux. Electric flux, I know formula is E dot dA. So here E into area will happen. So I will get 6i cap plus 5j cap plus 3k cap dot product with 30i cap. So definitely 6i cap and 30i cap will multiply. So 6 into 30, 180. So 180 is our final answer. Option 3 is the correct answer to our question. So we have successfully completed all questions in this section. Please feel free to comment your thoughts and provide your feedback. If you enjoy the solutions, please like the video and subscribe the channel for more such content.